So workshop next year in Gdansk. I will hold you to it. Have a good memory. Please make it so.
Yeah. We'll ask our CEO.
Hello, I'm here again. I'm Mäsak. I code in PL6. So today it will not be about Chinese, it will be about PL6. May I first ask the audience, how many here have written at least a line of code of PL6? Oh, that's cool.
Oh, you did?
Cool.
Oh, really?
Yeah, some of you more than others. That's fine. I should also give, I guess, fair warning. This talk will be full of cats. And, well, if you're an allergic, maybe cover your eyes. If you're wondering whose fault it is, it's Jonathan's fault. Again! As usual, yeah. So there's more than one way to model it. This is something, I would almost call it an obsession of mine. So I'm trying to drill down to the core of what we're all doing, almost no matter what application we're writing. There's a model in there somewhere. There's a nice quote I've heard someone say. I haven't found an attribution, but the quote is, inside every big interesting problem is a small interesting problem fighting to get out. So that's kind of what we'll be approximating here. So there's more than one way to model it. I don't mean the sort of money-making modeling business here. I mean the modeling inside of computing. Yeah, you go on. That would have led to a completely different talk, wouldn't it? So, what is a model? Aside from that obvious sort of photography definition. Well, a model is various things, and when you start looking at them, it's kind of not obvious that they even refer to the same kind of thing. A model is a small version of something, like a model airplane, for example, like this guy's airplane. Or a model can be sort of, before thieves do a break-in, it's sort of, they put a model of a bank. They used to do it with, you know, cardboard boxes and building also a small version of something there. But they use it basically to familiarize themselves with the bank. So, and then you go there and go there. So here you see a master thief planning. Nowadays they have digital equipment to do this, but the principle is the same. Or a model could be something like a model citizen, or like this model village. My wife took a look at this picture and she said, you would get lost in there. In my defense, so would probably anyone else. So, yeah. What do these things all have in common? So what really is a model? Especially what's a model for us in programming? What commonality can we find between these? And I've been thinking, and I've been listening to sort of luminaries give talks about this, and here's the definition I like most so far. A model is an approximation of something else, good enough for some purpose. Okay, that's vague, but it seems to fit basically what we just saw here. In computing, we use models to build these approximations. If you have a line of business system selling some products, you need a model inside to sort of make an approximation of what you're selling. You don't have actual products in the computer, you just have a model of it. The model is made of bits and programs, bits and code. And they don't have to really. If our computers were sort of completely based on quarks and strings, that would still work. So the digital medium here is kind of a coincidence, but it's something that we often end up with. Usually there's something else, like we say, it's something that has business interest here. But basically it could be anything else as well. It could be physical, or it could be non-physical, like a set object has a model inside of it, an array has a model inside of it. So it's a very general thing, and in order to nail it down and make it more concrete, let's do some live coding here. In PL6. So an example, I came up with an example. The Per Foundation, a mused feline hotel, is a place where exhausted lolcats go to relax, away from their demanding human thralls. So here's an exhausted cat that needs some relaxation. As an overview, we need kind of operations that we can do on this hotel. We need to be able to check in, check out, maybe register cats beforehand when the demand rises. And as we go along and as we code this, we should consider happy paths and sad paths. That is, what happens when we succeed at an operation and what happens when we fail at an operation. It's important to not forget these sad paths, because we need to fail gracefully, we need to know why something went wrong, and basically this is where we dig out our exceptions and make them part of our model as well. By the way, I put in cat hotel into internet images, sort of naively expecting there will be nothing about this, there will sort of just be garbage images. No, there is no actual cat hotel. And boy did I underestimate the internet. So here's a short selection. Longcroft luxury hotel for cats. This is just one room, here's another view. Looks quite luxurious actually. Cat hotel in Burbank, California. You can see the sort of the charming logotype. Clearly, this, after 3 examples here, this cannot be an isolated occurrence, so there actually are cat hotels out there.
They have jacuzzi.
That's a good question. It probably varies from hotel to hotel. This one claimed that they had room enough for 3, sort of in every room. Well, that does sound luxurious. Maybe a king-size bed or something like that. This room here is actually better than some hotel rooms I've been staying in. And this looks very cozy. Nice. This one happened to have the headline, Cat Hotel in London attracts celebrity felines. So now you know. I don't know what celebrity felines, maybe grumpy cat or ceiling cat or something. So, we are going to need a model for this cat hotel. Let's code it up. And I did a rehearsal this morning, but this will probably be completely different, especially since I expect your input here. I expect you to be, well, one thing trolls, and secondly, sort of my pairing partner. So let's do hotel P6. And since we're doing this the TDD way, the first thing we write is a test. Multi-main. When we start this program with test, we will use the test, and then given hotel object, just created here, we should be able to do a check-in. Okay, this is the first time we consider the API sort of. There is a cat checking in and there is a room that the cat checks into. So let's do that. Let's call the cat sort of Tom. And the room should be 101, like that. Okay, that seems to work. And we just want this to work. So after we get that far, we do an OK true and say able to check in. Now let's try running this. Call 6 hotel and with the test argument. Was that test? Yeah. Undeclared name, hotel use. So this is moving very slowly with test. We could have put that in immediately because we know it's needed. Hotel. Isn't it nice to have a class keyword? I think so. Don't need to load a module, right? No such method check-in. Okay, that also makes sense. By the way, I'm running more, so my error messages come sort of on a sub-second level here. Method check-in. That, oh, it should have the right argument as well. It's a cat and it's a room. And by the way, I know that these are strings, so let's put that in. Okay. Running. Okay, that passes. We now have the check-in operation. Now, some of you may react and say, but we didn't write any code here, we write an empty method. Well, apparently it does what we want. The test here checked for, are we able to call this method? Yes, we are. We have the right arguments and they match the parameters and everything's fine. So this is the happy part. We do need the sad part though, to actually make this work. So, how do we do this? We say, expect a failure here. Can someone suggest a sad path? What can go wrong in checking into a room?
No place.
There is no room. No such room.
No such room. Okay, let's take that one. We can come to no place after that. It's slightly more complicated. No such room. So expect that, and we pass in some code here, like that, and we say cannot check into a room that does not exist. All right. So now we do check in again with, I've taken out the cat, this is the cat Rita, trying to check into room Okay, this expect thing, it does not actually exist. We need to create it for our purposes, so it's a small helper sub here, expect, and it takes an exception, actually just an exception type, and it takes a block of code, block, and it takes a description. So let's just try to make this run first. What we need to do is basically to run the block of code, like that. Oh, and here we, just in case, we need to pass in the a new hotel. That's fine. And then we do a catch. And in the catch we just check, is it the actual expected exception type? By this point, by the way, I don't mean to talk down PL6 people, but I've probably used like 5 implicit CPAN models that are just included in PL6. So that's kind of nice. There's one what's it called? Try simple?
Try tiny?
Try tiny, that I'm sort of implicitly using now. When exception type, then we say, okay, we actually succeeded there, so okay, true, and then the description. Right? Otherwise we say, okay, false. Description. Okay, that looks reasonable enough. The catch, when it finds something else here, it will simply read through the exception and something else will have to cover it. So we basically have 3 cases here. Either we sort of succeed with the method without any exception, and then it goes to the okay, false here, or we catch exactly the right exception and then it does okay, true, or we get something unexpected, some other exception, and then it actually ends the program and aborts the program. These are the 3 cases we want here. Right, so we run this, it will say, could not find symbol no such room. Okay, that's this one here. I didn't create the exception class, did I? Okay, so let's create it here. Class x no such room. And if I were to create it sort of in its entirety, and I could probably write a test for this as well, it would be something like this. It has a room, and then it has a method message which says no such room. Okay, nice. Fantastic. Running it again, not okay, cannot check into a room that does not exist. So now we actually reached the point where we have to think a little bit about how to implement that. Well, we need a list of existing rooms, and that feels like a constant to me. Maybe one that we would sometimes want to sort of change and inject or something, but for right now we just do rooms here, and let's decide that rooms 101 to 114, and then maybe 201 to 214. Those are the rooms that exist. Okay, and beyond that we need to die if it's not that room. So die with the correct exception, no such room. Create it new here and pass in the room as a name parameter. Unless, and here we want to do a containership thing. How do we do that? We say unless room equals any of rooms, like that. Okay. That's something I may want to modify later, having sort of an external dependency on the class. But let's do it like that right now. X, no such room. Why does it not catch that? What did I miss?
Our no such room should be exception class.
Yes, thank you, that's what I missed. This exception. This is why I need my pair. Okay. Yay! So that's a sad part. Actually, did we go into requirements here? Oh, well. That's all the cat hotels again. So a cat should be able to check into a room. And maybe it shouldn't be able to check into 2 rooms at once. Okay, that's something else we need to consider. We already took care of this case. That's good. What else did we have? Out of rooms, right? So we have 2 side paths to consider here. Also, I really should have it done at the bottom, right? This is the way where you do it without a plan. So it's planless testing, but it sort of supplies the plan at the bottom. That's kind of nice too. Okay, which one do we tackle first? Well, let's tackle the sort of outer rooms because it's It sounds interesting. Can you all see this, by the way? How's the contrast?
It's okay.
Luckily, I don't have color coding, so. What do we call the exception? Outer room?
For what?
Sorry?
For what?
For what?
For which case?
For outer rooms.
Oh, out of rooms?
Yeah. Thank you. Sold out, yeah.
Thank you for your input.
That could work as well. Outer room. Now the problem is, you see I put in, what's that, 28 rooms here. There's no way I'm going to write sort of 28 check-ins just to fill up the rooms. So what we're going to do here is pass in a rooms parameter here. Yeah, this should work. Rooms. And that will be just 2 rooms. 101, 102. And we need to connect that one. So in the expect method, there should be an optional sort of rooms array here, right? And because it's optional, it can be empty, we don't need to send it. And then for hotel new here, we pass in rooms here. Right, and in the implementation later we need to sort of wire that up, but that comes later. So if we now just check in first room 101, that's Rita this time, and then comes Tom and takes room 102. Then it shouldn't matter which other room we try to check into. The problem isn't now that the room doesn't exist. The problem is that when Greg here, it's another cat, comes into room 1 and 2, then it gets out of rooms rather than no such room. So that exception sort of comes before. We cannot check in when we are out of room. Okay.
Shouldn't Greg check in into 1 and 2?
Maybe that's better. Yeah. And that perhaps should be another exception as well. Anyway, we just run it and see it fail. Oh, it fails for the wrong reason now. So let's add another exception like that. Out of rooms. Out of rooms. This one doesn't have any attribute, it just says out of rooms. Okay. There we go. It's not okay. How do we make it okay? How do we make it green? Well, here we could very well have
Rooms.
an attribute rooms, which will sort of nicely take in this one if it exists. But will default to rooms here. Will that work?
How will you indicate it's taken?
I think we actually need the default down here to make it work. But that's fine. Rooms is equal to. How will we need to indicate if it's taken? Well, here's where we actually need the model in the class. But let's solve it the easy way first. We would want to die with out of rooms. Just an exception like that. Unless, and here we just sort of put the problem. Unless rooms available. Like that. Okay. Well, now we need to write that method. And if you're wondering about the syntax here, this is a private method. Usually we use the dot, but when we use the exclamation mark, we declare it like this. Rooms available. Well, where does that information come from? It turns out that this method here needs to not just die in various cases, it needs to modify the class when something happens. And so it's because of these earlier check-ins, right, that we are out of rooms. We need to register that. Let's call that apply. We do a self-apply down here, where we sort of pass ourselves enough information to manage this. And the important information right now is room. So we say, well, store room here in an object that we apply. So that method, apply, will be quite easy to write. We just write to a private log here. We take log and push it. Apply as a certain element. We take log and push the event. And that's basically it. Well, we need log as well. Okay. Now we can write this one. Now we have enough information here. So from this array rooms, which we take from rooms, like this. Let's make a copy. I guess it will. Yeah. We look through the log. And each log here will be an event that we pick up. So let's do that. Log event. And we just remove the room from that array if we find it. Oh, it should better be a hash tag. Just delete it. Well, let's even write it like this. The rooms map over to. Which one should I use? Like this. Let's do it like this. For our rooms, we just add a key. Rooms $_ because it exists. Okay? It's available. I could probably do it true. Right? So for each event here, we say rooms, that event, and the room that we stored in. We just set it to false. And then we need to return the final value. How do we say if any room is available? We say any room's values equals true. Okay, this should work. Out of rooms. I forgot to make an exception here.
No.
Huh. Well, that fails for some other reason. That fails for the first one. But I think we're a bit too complicated there. What we're actually doing is checking room occupied, right? So that's an easier test. Room occupied. That, and we change this one. And we don't need to check all the rooms, we only need to hunt for the room we are trying to check into. This becomes an easier test as well. Room available. We just pass in the room. Yeah, that's better. So we just keep the for loop for events here. If we don't find anything, we return true because then it's available. And here we just say return false if the event consists of that room. Right? If event room equals that room. Okay. And here we pass in the room. So that should work.
The method name itself.
Oh, oops. There's a private method room, and it should be room. Thanks. You're half a second faster than still not fine. Where did we have that?
Exception.
Room. Right? Oh,
Yay.
and this passes. Yay. And what else did we have here? Maybe shouldn't be able to check into 2 rooms at once. Well, we could expand it into that. We'll see if we need it later. We'll punt that for now. But basically, you see how we sort of build out a model here for the things that we need. These public methods have a certain aspect to it. First, they do a bunch of validation. They do dies on things that they need to validate when they don't accept some data that is coming in. Usually they sort of delegate that to a private method, so that private method sort of takes care of all the validation logic. So these are just die, and that at the end we have a self-apply here. So let's speed things up and move to the next requirement. The cat should be able to check out, well clearly. Check the time here. Okay, that's fine. So we need a checkout operation. Let's just write a test for that and see if we make that work. So again, happy path, then we just need a given down here. Given hotel, we have Tom checking in and then check out. And what do we actually need to put in here? Well, technically we just need the room, right? Because Tom the cat is already checked in, able to check out. Okay, and we run that. We need to run the test first, and it says no such method checkout for inbound type hotel. Well, that's easy to fix. That's another public method here. Check out. By the way, isn't it nice that we can use dashes? There are some limitations, but sort of in the middle of an identifier, that's something to do. Okay, well that was easy. And we have some sad path logic here as well. For example, if we just do a checkout, room not occupied. If we just did this, for example, checkout from room 102, this shouldn't be allowed. Oh, I actually didn't end up using this room. Let's just see that this blow up cannot check out from an unoccupied room. Yeah, if we try to do that, then something is wrong. Okay, cannot find symbol room not occupied. That's most similar to this one, so let's copy that. Room not occupied. And we say room is occupied. Okay, let's try it again. Not okay, cannot check out from an occupied room because it expected an exception and it didn't get it. Nicely enough, we always have already have the room available here, so this should be a piece of cake. We just take this one and slightly modify it. Die, room, unoccupied, right? Room not occupied. Not occupied. If room available. Well, if it's available, then we can check out. And then we should have a self-apply here down the bottom, but I don't need it yet, so I don't put it in here. Well, except for an uninitialized value or type here, everything passed. What might that be? Let's ignore that for now. The test passes it anyway. So here you see the general course of things. We put in die things for each sad path. We put in the apply thing here for the happy path. The apply thing is what allow these private methods to later come in and validate things. So when we will need this self-apply here? Well, basically when we check the consequences of someone checking out. That's when we're going to need those. And probably we should have a bit more information here, which should say that this object is actually a check-in action. We should perhaps say which cat checked in so we can keep track of that. But that's easy to expand afterwards because these are just sort of untyped objects. All right. Moving forwards. Afterwards we could code requirements that, okay, now the hotel is growing so popular that we need to pre-reserve things, for example. So you reserve a stay and you're guaranteed a room if there is enough rooms when you do the reservation. So that's slightly safer. Well, one, this introduces the notion of time, because rooms are reserved for a particular duration. So then we need to handle time inside of our module. And just like we started injecting rooms here, we actually never used it, but you saw the principles. We could inject time and basically say in our tests, sort of, meanwhile, 5 days later, when the customers actually arrives, we check for certain things like that. A second thing that we need to make sure here is that just because you reserved a room, you shouldn't be totally blocked from checking in. Maybe there are a lot of free rooms that summer or something like that. So it should be a sort of an optional thing, and there shouldn't be sad paths that totally block you from checking in if there are free rooms. And then perhaps the model grows here. In order to make more profits, we have sort of several levels of rooms that cost different amounts. Of course, we have normal rooms, we have meow rooms, and then we have perfect rooms. And we should sort of flesh out our model to be able to handle that as well. We should consider what the relation is between a pre-reservation and the check-in, because you reserve a certain level of room here, and then you check in probably the same level, right? But a cat customer could come in and say, yeah, actually, I reserved the meow room, but now I want a perfect room. It turns out I have the budget for it, and so on. Or they could downgrade, and both of these actions should sort of be allowed by the hotel, but we should be a bit careful of doing them, because we don't want to block other cat customers who have already reserved a certain level. So it becomes kind of an intricate model here, and already for this kind of simple domain, we're dealing directly with the interesting qualities here of the model. And the way in the live demo that I showed to be coding, I believe that's a really, really sort of close way of modeling those things, of just doing validation. Basically every line of code I write here is sort of directly about the model and what things are possible and what things are not possible. And the order of the things, the exceptions that we should throw when we die and so on, are also significant. There's a little bit of overhead with this event log that we keep having here, and the apply private method, but those things are minor compared to sort of all the relevant things we're talking about. So this brings me to projections between models. We know from sort of the MVC patterns that are sort of turned popular in the 1980s and then that are still popular today on the web and in graphical user interfaces and so on, that we have these models and we basically project out into the views that we need. And that's a really powerful notion. It's very appreciated, for example, that we can have several views per model. That's well known. Slightly well known is that one view here could sort of serve various models and have sort of several projections going in. If you want to compare it to something, we could compare it to, for example, a join in a SQL database. That's basically what we're doing here. We're sort of combining all the relevant information from here with all the relevant information from here. So these two concepts, sort of models that do things and views that show things, are really powerful here. And the projections are sort of the important part in what information do we carry over between them. So just to be clear, modules are where things happen. If an update happens to the application, it happens inside of the model. And then views are just there to present derived information. So if you see some information in the view, it must have come from the model. It must have been stored in the model before. So here with views, we could basically start to think about the graphical user interface, right? There's someone in the lobby of the cat hotel who needs to know sort of a blink of an eye decision which rooms are free and which rooms are occupied, because otherwise they cannot safely check in a customer when they arrive. Or they would have to do a lot of trial and error, and the model will say no, 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 occupied, and that's not a nice user experience. So this is basically the first time we need to think about how to represent the information for an actual user on an actual screen. And so far we've avoided having like an array of rooms or something like that. But this is the first time we sort of need to present it on the screen, and that's where we build up all the information about the array of rooms. Moving on, maybe the view could actually be a bit proactive and suggest an optimal room to check into. Like if the cat reserved a normal room, then find a normal room and sort of mark it on this view and say, yeah, you could just click on this one. It needs to be a bit flexible, again, because the cat can come in and say, no, I actually want a meow room or something else. So it needs to be a suggestion here, again, to keep the application flexible enough. So, now a little bit of cat theory, just to round things off. Category theory is a branch of mathematics which basically has a very small number of concepts. It's a bit annoying because all the concepts are sort of related in a very tight ball. You can read about them and go nod, nod, and then the day after you've forgotten everything, so you need to reread it. The basic idea is really simple, and you recognize this from sort of the layout of the models and views that we saw before. You have, in a category, you have objects, and you have arrows going between the objects, and then you have one simple operation called composition, which says if you have two objects sort of that bounce between objects in a row like this, then you can combine them and make a bigger arrow. If this sounds familiar, that's basically what we're doing in functional programming, saying, okay, if you take a small function and another small function and you run them sort of one after each other, well then that's function composition, so we get a bigger function that does both. Well, fine, that's nothing revolutionary. But what mathematicians use category theory for is to basically restate an entire field of mathematics inside of a category like this. And it turns out you can do this surprisingly often. The field just has to have something like functions, not necessarily functions. Could be sort of ways to transform topologies for each other, between each other or something like that. And then they take entire fields and map them as categories and say, okay, this field over here is actually a bit like that field over there. And you start to see hidden connections between completely disparate fields of mathematics. That's kind of cool. I'm going to save you most of the trouble of studying category theory and just give you the spoiler here. It turns out that the objects are actually not important at all. The direct reason for that is that the category guarantees that you always have an arrow from an object back to the object itself. So you could just throw away the objects and keep those sort of loopy arrows, and they would completely substitute for the objects. But it also teaches us something important, that it's not the values here that matter. When you're doing programming, it's not the actual values that are important. They are sort of completely arbitrary, all of them. What's important is the ways to go between the values, the ways you map between things. So category theory sort of warns us of thinking too much about values or attributes or objects or things like that, and say that the valuable things sit in the methods or constructors or the dependency injection pattern, that sort of we take something into the model and parameterize it. And that's basically what we see in this way of coding. It's all in the methods. We do very, very little in the attributes of the model. There's a cool trick here where you start talking about the arrows themselves as objects. So take your function and pretend it's an object. Category theory lets us do that by showing in a rigorous way that the object contains just as much information as some arrows or other. This is basically the idea between first-class functions. So you pass around functions inside a program, and they are your arrows, but you treat them as values, and they are your objects. So it's kind of a step back from saying only arrows are important. When we treat arrows as objects, it turns out we get a much more awesome category. It gets more powerful. Basically, it's like flipping a switch and turning the category Turing complete. Because when you have objects that behave like this, that have sort of an arrow-like nature, well, then you have lambdas inside of your category. So it gives some hint here of why events are so general and powerful in the model, because the events are these objects that represent function. If you think about when we actually store an event, it's as the result of having called a method. So all the information that went into the method call, it sort of gets stored as the event inside of the model. Kind of cool. Just a quick summary. It's nice to be able to work in a model that's sort of free from all outside concerns. And this way of doing it points a way to do that. Our two weapons are basically ignore outside concerns or inject them through dependency injection, like we started to do with the rooms. TDD here helps a lot too. In fact, TDD as an ultimate endpoint seems to point to this way of doing things. TDD wants all the concerns to be either ignored or dependency injected away. So all you get is this small interesting problem that was fighting to get out. MVC teaches us that it's nice to have a core model here, or several core models, and then derive all the view information from that. We didn't actually do it, but you can imagine how that comes about. You could put in an observer pattern there, for example, which basically ties this talk to what Jonathan said yesterday. So you could have a view automatically update thanks to these supplies and taps, for example. Just connect the things in the view with the things in the model, and it will reactively update for you. The core model needs to be general enough to support all present and future projections. Well, events do just that. Events just say what information came in. It doesn't take any stance or anything like that. If we were silly enough to put in an actual room array inside of our model instead, well then we couldn't do any modification to it. We couldn't do all the possible predictions. But with events, we can do all the possible predictions. And category theory kind of sort of explains that, is if we spin to it. So there we go. Thank you. This one says my time is up. Maybe there are any questions. Or just stunned silence. That's fine.